Hello everyone, my name is Sagar Tiwari and I'm a student at the University of Florida. The topic that I've chosen for my project is email spam filtering using supervised learning algorithms. First, let me take you through the introduction for this project. Internet came into existence in the late 1980s and since then it has connected people across the globe. People have reverse engineered the internet, but there are also people who have done it with malicious intent. Internet has enabled a lot of individuals or group of individuals to develop their ideas into businesses. People have started using emails to spread the word about their businesses to attract potential customers. But this is where the picture of spam emails comes into place. What is a spam email? Unwanted emails that are sent anonymously, mass mailed, and are unsolicited fall in the category of spam emails. Usually, 80% of the emails that we receive are spam emails. Even though they don't affect our privacy directly, they end up occupying a large chunk of our inbox capacity. Some hackers use spam emails to extract information from the user. This information may be financial, personal, or it could be professional. Victims of spam emails have collectively lost more than $15 billion in the past year. There are 4 kinds of spam emails, or probably I could say there are more than 4 kinds of spam emails, but I have mentioned only 4 of them here. The first one is spam-vertised sites. As the name suggests, these are the kind of emails that advertise products. They contain URLs to other websites. Then we have phishing emails. Phishing is basically used to extract financial information from the users by asking users to enter their legit bank information on a fake website. Then comes the 419 scams. These kind of spam emails offer huge sum of money to the users in return for a small initial payment. Image spam. In these kind of emails, the content or the body of the message is displayed as a GIF or JPEG image. Usually the word filters that basically categorize an email as spam based on what kind of words are there in the email are unable to detect these kind of spam emails. There are some key terminologies for these projects. The first one is spam emails. As I've already discussed, most of the unsolicited or junk emails are the spam emails. Ham emails are basically the non-spam emails which contain legitimate content in them. These are the emails that we usually want to keep in our inbox all the time. Accuracy is the extent to which the algorithm correctly predicts an email as spam or ham. Then we have the false negative, which means when a spam email is classified as a ham email. We have a false positive, which means when a ham email is classified as a spam email. Execution time, the total time taken by the algorithm to execute completely. There are 3 kinds of algorithms which I have talked about in my project. The first one is naive Bayes, the second one is k-nearest neighbors, and the third one is random forest. Before talking about the algorithms, let me give you an insight about the dataset that I'm using. I'm using the UCI spam-based dataset, which has a total of 4,601 emails, out of which there are 1,813 spam emails and 2,788 ham emails. The total number of attributes in this dataset is 58 and the total number of continuous attributes of word frequencies is 48. Now let's talk about the naive Bayes algorithm. Naive Bayes is a supervised learning algorithm based on the underlying Bayes theorem. The algorithm is trained using a training data set and it generates the classifier model for us. The naive Bayes is based on the model of conditional probability. Conditional probability means probability of a specific event happening if and only if some other event has already taken place. In our case, the spam-based dataset is a continuous dataset, therefore we choose to use the Gaussian naive Bayes distribution. Here I have mentioned the formula which I have derived from the Bayes theorem, and this is the formula that I have used in my algorithm. On the left hand side, the formula means probability that an email is spam given that a specific word is present in it. On the right hand side, I have expanded that formula to include some other concepts of conditional probability. The way this algorithm works is we approach the data, that is, we divide the data into classes. For each continuous attribute present in the data, we find its mean and variance for each class. Below, I have mentioned the formula that probability of a particular attribute X if and only if it's present in a specific class C. I found out class probability by simply multiplying using the assumption that all data features are independent. Then for a test data point, we find out the class probabilities. If the probability of spam is greater than the probability of ham, for that test data point we classify it as spam. The results are as follows for this algorithm. We got an accuracy of approximately 81-82%. The execution time was 1.4 seconds or 1.5 seconds. The false negatives was 16% and the false positive were 2%. The next algorithm is the k nearest neighbors algorithm. Here the word k represents the total number of neighbors or total number of data points that we are considering with respect to the test data point. We use the Euclidean distance between the test data point and its k nearest training data points to classify the test data point to a certain class. This is a very slow algorithm as we are not doing any training phase. The Euclidean distance is given by the following formula, which you can see in this slide. After that, it checks if the majority of those neighbors represents emails of ham emails, represents spam emails or ham emails, and accordingly classifies the test point. In this graph, you can see as we vary the values of k, we get a varying accuracy, and as we vary the value of k, we get different total time taken in seconds. We cannot say that there is a linear relation in this because the value of k and accuracy or total time taken seconds is not directly proportional. These are the results which I got. In the accuracy column, you can see that most of the accuracy usually tends to be around 80% and the total time taken tends to be around 56%. This time is a lot larger than the time we obtained in the naive-Bayes algorithm. Then we have the random forest algorithm. The general approach of this algorithm is that it creates a bunch of classifiers from a training dataset. Each of these classifiers predict or vote to classify the email as ham or spam. The classifiers are most effective when there is a general disagreement between them on the input training dataset. The classifiers in this case are the decision trees. Since this algorithm we deal with a collection of trees, we get the term of forest. We divide a training dataset in random groups or subsets. Each of these is used to create a decision tree. Also, the manner in which we traverse the tree to make a decision is in a random order. All of the training dataset is not used to create a decision tree and some of the training data is left behind. Here you can see a graph between the number of decision trees that we have taken in the algorithm to the accuracy. We can see that somehow the accuracy increases as we increase the number of decision trees. This is because as we increase the number of decision trees, the chances of classifying an email as spam or ham accurately increases. This is basically how the algorithm works. First there is the input stage, then using the input, which is basically the training data, we make different decision trees. Here there are 3 decision trees. Then we combine the votes for majority, that how these decision trees have classified the email as spam or ham, and then based on the majority we get a final classification for that specific email. Here you can see the results. The random forest with 1 has 83 and the accuracy significantly increases as you increase the number of decision trees. This basically tells us that the more decision trees we have, the more accurate our results will be. In conclusion, I can say that the random forest is the best algorithm because it has the highest accuracy, which is around 92%, and has the lowest execution time, which is around 0.09 seconds. The naive-Bayes algorithm is comparable to k-nearest algorithms in terms of accuracy for 81%, but the runtime of both of them is drastically different. The k-nearest neighbor takes approximately 57 seconds to run, whereas the naive-Bayes takes around 1.5 seconds to execute. Therefore, the order of preference of algorithm for this dataset is the first priority, or the best algorithm is the random forest, followed by naive-Bayes, and the least is k nearest neighbors. But this result just holds for this dataset. If we change the datasets, the performance of these algorithms may differ. Now, let me show you the code that I have developed for my project. This is basically the naive-Bayes algorithm which I have developed. You can see here that the algorithm starts here. It reads the spam-based dataset, and then here we have divided the training and test data into 70% to 30% ratio. Then from here The algorithm is run and this is the code for it. Let me run the algorithm for you and show you that. Here you can see the accuracy is 81.5%, the false negative is 16%, the false positive is 1.5%, and the total time taken is 0.3 seconds. Let me run the random forest algorithm for you now. The code for the random forest is present here. This is the code for the random forest. Okay, so here we can see the accuracy rises up to 92% and the false negative percentage decreases to 6.15% and the false positive percentage decreases to 1.4 seconds. This algorithm takes 0.5 seconds to execute. Now let me run the KNN algorithm for you. The problem with this algorithm is it will take a while before it executes. Okay, so the KNN has stopped executing, and here we get the results. The accuracy is 79%, the false negative is 10%, and the false positive is 9%. The total time taken for this algorithm to execute is 59 seconds, which is a lot of time. Let me try to change the number of neighbors that we are considering. Suppose we are considering just 5 neighbors. Let's see how the algorithm gives us a different result for it. Here, with the number of neighbors increased to 5, we can see the accuracy has gone up by a little. It's 81% now. The false negative have gone down. False positive has increased a little, but not by much. And the total time taken to execute the algorithm is 58.64 seconds now. So we can see that this is a very slow algorithm. Let me show you one another thing. Here you can see for the random forest algorithm, I have increased the number of decision trees to 15, and let's see how it affects the execution time and the accuracy. Here you can see the accuracy remains 91%, the execution time of the code goes down to 0.09 seconds, which is less than a second. The false negative is 6% and the false positive is 1%. That's all for my presentation. Thank you.